Okay, this is the Unit 6 review. Before we get started, we're going to head over to our calculators and make sure that they're in the correct mode. Sometimes when you do like cube roots, let's say the cube root of -27, the calculator, because of its settings, will tell you that it's an imaginary complex number, which is not the case because cube roots should always give you just a regular real answer. So what we're going to do to fix that is we're going to hit Shift Menu, and right beneath where it says Rad, we're going to go into complex mode. We're going to take it out of the complex mode. So to do that, we're just going to hit F1, and then if we go back to that same question, enter it again, now it works. So that's how you fix your calculator. I'm not sure what the calculator is doing exactly, but I just know that it has to be in real mode in order for this to work right. Okay, first question. Number 1 says 16 to the -5 halves. Write the expression in radical form and then simplify. So the first thing we have to do is we have to fix the negative because you can't have negatives. So I'm going to put that 16 down at the bottom. When it comes down to the bottom, now it's a +5/2, and then 1 is on top. Then what we're going to do is we're going to convert it into a radical. The bottom number indicates that it's going to be a square root. So I'll put square root of 16. If you want, you can put the 2 out here. And then you're going to put the 5 on top of the 16 as its exponent. And then at that point, you can just type that into your calculator. So I'm going to go into my calculator and just hit Shift X squared 16 to the 5th power. Now the answer is 1024, but it's not just regular 1024. The square root of 16 to the 5th power is at the bottom, so the answer is going to be 1/1024. That's our final answer. Number 2 says 27 to the 2/3 power. There's no negative here, so we can actually just turn it into the radical. So 27 goes inside of a radical. The bottom of that fraction is a 3, so I'm going to put 3 on the index, the little step of the radical, and then the exponent of 2 goes on the 27. The 27 has a parentheses around it in the original problem, but I'm just going to not put it because it's positive, so it doesn't really matter. If there was a negative, I would put it. That really does matter. So this one doesn't have one, so I'm not going to put it. So in the calculator, we're going to type in Shift parentheses 27 to the 2nd power. And that answer is just 9. Number 3 says 8 to the -1/3 power. Again, we have that negative. So I'm going to put my 8 at the bottom and write it to the +1/3 power. The +1/3 power now can be converted into a radical. The bottom is a 3, so that's going to be the index. So it's going to be 8 to the 1st inside of a cube root, and that's all going to be at the bottom. Then we go into the calculator, and when I type this into the calculator, I don't even put the fraction. I just figure out what the cube root of 8 is. It's 8 to the 1st power, so again, when there's a 1, you don't have to type that in. So that answer is 2, so we just have to make sure to put the 2 down at the bottom since the cube root of 8 was at the bottom. So the final answer is just 1/2. Okay, the next group of questions says write the expression so it has rational exponents and then simplify. So a rational exponent is something that has an exponent that's a fraction. So I'm going to put a 1 for the exponent on this -64. And because that's a negative, I'm going to put that in parentheses. So -64, put that -64 in parentheses. And then I'm going to put the exponent is 1, so it's going to be to the 1/3 power. And then you could just type that into the calculator to simplify. So in parentheses, -64, -64, and then to the 1/3 power. So the answer is -4. Okay, number 5 says parentheses, 5th root of 32, and then outside the parentheses to the 3rd power. Now that parentheses being there, it's not really necessary because the 32 is positive. So I can just put 32, and then the index is 5, so that puts the 5 at the bottom of the fraction, and then the exponent is 3, so that puts it at the top. Then again, we could just type that into the calculator. So 32 to the 3/5 power. That answer is going to be 8. Okay, the next one says negative on the outside of parentheses, 4th root of 625 to the 3rd power. Now, you are allowed to have negatives, just not on exponents, so we don't have to put this down to the bottom. So what I am going to do, though, is I'm going to put negative outside of a parentheses with 625 on the inside. And then I'm going to put a fraction for the exponent with 4 at the bottom and then 3 at the top. Then I'm just going to type that into the calculator. So negative parentheses 625 to the 3/4 power. So it's negative 125. Okay, learning target 2 is simplifying expressions. It says simplify the expressions, assume all variables are positive. So the first one, number 7, is 4 to the 1/5 times 4 to the 3/5. So anytime you have two bases being multiplied, you just add the exponents. I think that says 3/5. Hopefully it does. So we keep the base as a 4, and then 1/5 plus 3/5 is 4/5. It doesn't say simplify, so I'm just going to kind of leave that there, but yeah, that's pretty much the answer. Number 8 has parentheses 256x squared over 81, and then close the parentheses to the 3/4 power. Now this one, you have to distribute the exponent to everything on top and everything on the bottom. So you end up with 256 to the 3/4 power. And then x to the, when you multiply 2 times 3/4, you just multiply 2 times 3 and then put it over 4. So 6 over 4. But 6 over 4 reduces to 3 over 2. So I'll just leave it as 3 over 2. And then down at the bottom, I have 81 to the 3/4 power. Now, even though it doesn't say simplify, I'm going to type these in to the calculator. As a matter of fact, let me type in 4 to the 4/5 just to make sure from the last problem. And if it gives me a decimal, I'm not going to put it down. Yeah, so on number 7, it gives me 3.03. I'm just going to leave it as 4 to the 4/5. But a lot of these are set up to where when you type them into the calculator, they'll give you a nice answer. So like 256 to the 3/4 power. So for example, 256 to the 3/4 power gives you 64. So this would be 64x to the 3/2. And then down at the bottom, we have 81 to the 3/4. So I'm going to put that in the calculator, 81 to the 3/4. And that gives you 27. So the final answer is 64x to the 3/2 over 27. Okay, number 9 also has a set of parentheses with 8x to the 9th on top and y squared at the bottom. Then you have the 1/3 outside of those parentheses. So again, just like the last problem, we're going to distribute the exponent to every parentheses, or everything inside the parentheses. So I have 8 to the 1/3. X to the 9 times 1 is 9. 9 divided by 3 is just 3. And then at the bottom, we have y to the 2 times 1/3 would just be 2/3. Then if you type 8 to the 1/3 into your calculator, 8 to the 1/3, it's just 2. So we have 2 on top with x to the 3rd on top, and then y to the 2/3 at the bottom. That's our final answer. Okay, the next one is a subtraction problem. It's a cube root of 54 minus the cube root of 128. Now the big thing about this one is in order to add and subtract, they have to match on the inside. So what we have to do here is we have to break them down using our cubes list. 54 can be broken down into 27 times 2. And the reason why I picked 27 is because 27 is a perfect cube. So then the cube root of 27 would just be 3, and then we would have the 3rd root of 2 still attached to it. Now 128 can be broken down into 64 times 2. So that's going to be the cube root of 64 and the cube root of 2 being multiplied together to get to the 128. The cube root of 64 is just 4. So this is going to say minus 4 cube root of 2. So 3 cube root of 2 minus 4 cube root of 2. When you're adding and subtracting any radicals, as long as the radicals match, you just use the fronts. So 3 take away 4 is negative 1, and then cube root of 2. So you can write it as negative 1 cube root of 2, or you can just leave it as negative cube root of 2, which I've done. Okay, number 11. Number 11 says the fifth root of 5, x to the fifth, y to the sixth, and z to the 12th. Okay, so we're just going to do each one of these individually. So first, 5. 5 is not, it doesn't have any factors, so it's just going to stay fifth root of 5. Now for the exponents, you want to see how many times the index goes into the exponent. So 5 goes into 5 one time, so that means x to the 1 comes out. Now 5 goes into 6 one time without going over, so that'd be y to the 1. But 5 times 1 is just 5, so that's 1 short. So that means I'm going to have an extra y inside of a fifth root. 5 goes into 5 goes into 12 two times, so I'd have z squared. And then 5 times 2 is 10, so that was 2 short. And so I'd have a fifth root of y squared, or not y, sorry. That's going to be a z squared. So I would have the fifth root of z squared on the inside. Then we just have to put all of the stuff that came out in the front. So I'd have x, y, z squared. Then everything inside of your fifth root goes into one single fifth root. So I'd have inside the fifth root 5y z squared. So the final answer is x, y, z squared, fifth root of 5y z squared. Okay, learning target 2 is also just, we're still in the same learning target. We just have to, excuse me, we just have to simplify the expressions still. So this one says, number 12 is the square root of 81, x to the 16th, y squared, and then z to the 20th. So we have 2 for the index. The square root of 81 is just 9. The 2 goes into x to the 16th 8 times. So x to the 8th comes out with no leftovers. 2 goes into y squared once with no leftovers. And you can put y to the first power, but I don't ever usually write the 1. And then 2 goes into z to the 20th 10 times. So this problem doesn't have any leftovers, so we're just going to be left with 9x to the 8th, y, z to the 10th. Okay, number 13 wants us to multiply. So I'm going to multiply radical 2 times radical 10. That's going to give me radical 20. Then I'm going to multiply radical 2 times 2 radical 5. So that's going to give me positive 2 radical 10. Then I'm going to multiply negative 3 times radical 10. So negative 3 radical 10. And then negative 3 times 2 square root 5 would be negative 6 radical 5. Now right away, the radical 10s can combine. So in the middle, I'll have negative radical 10. The 20 can break down into 4 times 5. So the square root of 4 is just 2 radical 5. And then if I bring down the last term, which was negative 6 radical 5, now that matches the 2 radical 5. So 2 minus 6 is negative 4 radical 5, and then minus 10 inside of the square root. So negative 4 radical 5 minus radical 10. Next problem is very similar. 1 times 2 is just 2. 1 times negative radical 5 is negative radical 5. 2 radical 5 times 2 is going to be 4 radical 5. And then 2 radical 5 times negative radical 5 would be minus 2 radical 25. So right away, again, the middle two terms can combine. There's a 1 in front of that first 1 radical 5. So negative 1 radical 5 plus 4 radical 5 would give us positive 3 radical 5. Now on the right, I have negative 2 times the square root of 25. Well, the square root of 25 is just 5, so that's actually 2 times 5, so that's negative 10. And then we have the 2 that was in the very front, so now 2 minus 10 is negative 8 plus 3 radical 5. That's our final answer. Okay, next question. Number 15 is 3x to the 2/3 times 4x to the 1/3. So we're going to do the 3 times 4 like, just like regular numbers. 3 times 4 is 12. And then we're going to add the exponents on the x's. 2/3 times 1/3 is 3/3, but 3/3 is just 1. So the final answer is just 12x. Number 16 is very similar, so we're just going to do negative 2 times 5, so that's negative 10. And then we have to add up 1/4 plus 1/2. They don't have common denominators, so I'm going to put that into the calculator. 1/4 plus 1/2. And it gives me 3/4. So this is going to be 10x to the 3/4 for my final answer. Okay, number 17, still in the same learning target. This is the one where we have to solve for y, but there's a way that I'd like to do it. The goal is to turn everything into fractions. So on that left side, I have x to the 3/5 over 5th root of x squared. So that left side is going to become x to the 3/5 over, if I convert 5th root of x squared, it's going to become x to the 2/5 because the index is always the bottom. Once we can get those to be all fractions, then we can just write 1x, and then we can just subtract the exponents from top to bottom. So we would have x to the 3/5 minus 2/5, so that's going to give me x to the 1/5. Now the right side of the problem says x to the y, so I'm going to put equals x to the y. And once we have just a single term on each side, we can just set the tops equal to each other. So that means y is equal to 1/5. That's my answer. Number 18 is very similar, x to the 4/5, and then at the bottom we have x to 5th root of x to the 7th. So I'm going to write this as x to the 4/5 on top, and then at the bottom we'll have x to the 7/5, because the index is always the bottom of your fraction. Once we have one fraction on top and one fraction on the bottom, excuse me, we'll have x to the 4/5 minus 7/5. 4/5 minus 7/5 would be negative 3/5. So x to the y is equal to negative x to the negative 3/5. So negative 3/5 is what y is equal to. Okay, number 19 says the 4th root of x over x to the 5th in parentheses to the 1/4 power. So the top one is going to become x to the 1/4. The bottom one, if you multiply those exponents, is going to be x to the 5/4. Now we could just subtract them. So x to the 1/4 minus 5/4. 1/4 take away 5/4 is negative 4/4, which is negative 1. So x to the y is equal to negative 1. That means y is equal to negative 1. Okay, number 20 says the cube root of x on top, and then x squared in parentheses to the 1/3 power. So this is going to give me x to the 1/3 on top. And then down at the bottom, it's going to be x to the 2/3. So then we have x to the 1/3 minus 2/3. So that's going to be x to the negative 1/3 equals x to the y. So that means y is equal to negative 1/3. Okay, so now let's see. Number 21, learning target 3 is on solving equations. It says circle the error, explain the mistake that was made, and finish solving correctly. So this one is the square root of 7 minus 2x is equal to x minus 2. First thing to do is put parentheses to get the 7 minus 2x out. So they put it in parentheses and square it since the index is a 2. That means that on the right side, it's also parentheses x minus 2 squared. Now the mistake is going to happen on the right side, and I'm going to circle x squared plus 4. The reason why I'm circling that is because when you have x minus 2 squared, you don't just distribute the exponent. You have to actually write x minus 2 and x minus 2. You have to write it out twice and FOIL it. So x times x is x squared. X times minus 2 is minus 2x. Minus 2 times x is minus 2x again. And then minus 2 times minus 2 is plus 4. So we'll have x squared minus 4x. Let's do that again. X squared minus 4x plus 4. So that's going to replace the x squared plus 4. And so I'm just going to bring down the 7 minus 2x, and then I'm going to continue solving it from there. So I'm going to subtract 7 from both sides, and then add 2x to both sides. So I have 0. 0 is equal to x squared minus 2x minus 3. This is a simple ABC, so I should be able to factor it. And this one is going to be fairly simple because the only two numbers that multiply to 3 are 3 and 1. And to make it equal to a negative 2, it's going to have to be negative 3 and plus 1. Now solving these is relatively easy because all you have to do is switch the signs. So x is going to equal 3 and x is going to equal negative 1. Now we have to check them. So to check them, we're going to put 7 minus 2 times 3 inside their first radical on the left side. So 7 minus 2 times 3 is 6, so that's going to be square root of 1. So that's just going to give me 1. On the right side, I'm going to have 3 minus 2. 3 minus 2 is also 1, so that checks out. So x equals 3 is definitely an answer. Then we're going to do the same thing with negative 1. So I'll have the square root of 7 minus 2 times negative 1. Negative 2 times negative 1 is plus 2. 7 plus 2 is going to give me the square root of 9, which is just 3. Then on the outside, we're going to have 3. This is on the right side. 3 minus negative 1. Is that right? Yeah, no, I lied. Just kidding. Hang on a second. I need to plug in the negative 1. So the right side is x minus 2, so it's going to be negative 1 minus 2. Negative 1 minus 2 is equal to negative 3. Positive 3 does not equal negative 3, so x equals negative 1 is going to be the extraneous solution. Okay, number 22 says the cube root of, 3 times the cube root of x plus 4 is equal to 12. We got to solve each equation and identify extraneous solutions. First thing is I have to get rid of the 3 on the outside. Your radicals have to be by themselves with nothing outside before you can use the exponent to get rid of them. So we'll have the cube root of x plus 4 is equal to 12 divided by 3 is just 4. Then we're going to raise this to the third power. Do it to both sides. The cube root raised to the third power, they cancel each other, so you're just left with x plus 4 on the left, and then on the right side you have 64. Then we subtract 4 and subtract 4, so we get x is equal to 60. Now if you just do a quick check of that, if you put 60 in for x, it's going to be 60 plus 4, so that's 64. The cube root of 64 is 4, and then 4 times 3 is 12, so that checks out. That's the correct answer. Number 23 down below says 2x plus 15 to the 1/2 power minus 2 is equal to 3. So again, we don't want that minus 2 there, so I'm going to plus 2 to get it to the other side first. So I have 2x plus 15 in parentheses to the 1/2 power, and that's going to be equal to 5. Now, if I have a 1/2 power and I want to get rid of it, I raise it to the reciprocal power. The reciprocal of 1/2 is 2 over 1, but I'm just going to leave it as 2. 2 over 1 is the same as just 2. So I'm going to put brackets on the right side and raise that to the second power also. The left side, we just have 2x plus 15 is equal to 5 squared, which is 25. And I'm going to subtract 15 from both sides. I'll get 10 is equal to 2x. Then just divide by 2. So x equals 5. Now we are going to check this. So if I put 5 inside the x, 2 times 5 is 10. 10 plus 15 is 25. 25 to the 1/2 power is basically saying 25 to the first and then square root of that. So the square root of 25 is just 5. 5 take away 2 is 3. So that does check out. That's the correct answer. Okay, the problem number 24, it says square root of x squared minus 2x. And then after that is minus 3 square root x minus 2. So what we want to do is first we want to get these on each side of the equal sign since it's equal to 0. So I'm going to add 3 square root of x minus 2 and add 3 square root of x minus 2. So I'll have square root of x squared minus 2x minus 3, no, equals, just kidding, equals 3 square root of x minus 2. So we're going to go ahead and put that into the parentheses and square them. Now the left side is easy because you're just left with x squared minus 2x since the square root and the exponent cancel. On the right side, you have to be really careful because this 3, a lot of people forget about it, but that 3 is also being squared, so that's going to be a 9, and then parentheses x minus 2. The x minus 2 comes out of the radical since you're squaring it. So now I can distribute the 9, so this is 9x minus 18 is equal to x squared minus 2x. I'm going to subtract 9x, and then I'm going to add 18. So I'll have x squared minus 11x plus 18 equals 0. Now I can factor it. This is a simple ABC. Two numbers that multiply to 18 but also add to 11 is 9 and 2. And to make it a negative 11, it's got to be negative 9 and negative 2. So that means that our two possible solutions are going to be 9 and 2. Now I have to check them, so I'm going to put them into the calculator because it's going to be a lot faster. So let's see, shift x squared parentheses 9 squared minus 2 parentheses 9. That's the first radical. Then we have a minus 3 on the outside. Shift x squared, shift x squared, and then 9 minus 2. If this is the correct answer, this should give us 0, which it does. Then we can go and check the 2, and I don't have to retype the whole problem. I just have to go in and delete all the 9s and turn them into 2s. So there's the first one. There's the second one. And there is the third one. So both of them give us 0. So those are both going to be our solutions, and none of them are extraneous. Okay, the next one says the cube root of 120x plus 30 is equal to the cube root of 240x minus 10. So right away we're going to cube these. We're going to raise them to the third power. That's going to cause all of the cube roots to cancel. So I have 120x plus 30 equals 240x minus 10. So I'm going to subtract 240x to get the x's to one side. And I'm going to subtract 30 to get those to the other side. So I'll have negative 120x equals negative 40. Then I'm going to divide by negative 120. So x equals 1 over, I believe that is 3. And it's going to be a positive 1/3. So then again, I'm just going to check them in the calculator, make sure it gives us the same number on both sides. Let me delete all this stuff because it bothers me. Yes, delete, delete, yes. Okay. So shift parentheses 120 parentheses 1 over 3 and then plus 30. So that gives me 4.1212853. Then I'm going to check the cube root on the right. So this is 240 parentheses 1/3 1 over 3. Close the parentheses and then minus 10. Now it's not a big deal that it gives us a decimal. We just have to make sure that both of them give us the same decimal. which it does. They're the exact same decimals. So x equals 1/3 is the answer, and it is not extraneous. Okay, number 26 is very similar, except it's to the 1/4 power, so that means we have to raise it to the 4th power. The reciprocal of 1/4 is 4/1, but 4/1 is the same as just 4. So I'll have 57 minus 4x is equal to 69 minus 2x. So I'm going to add 2x to get all of my x's to the left. And I'm going to subtract 57 to get all of my numbers without x to the right. So I have negative 2x is equal to 69 minus 57 is 12. Then I just divide by negative 2. So I get x equals negative 6. Then I go and check it in the calculator. So I'll have in parentheses 57 minus 4 parentheses negative 6. Close the parentheses, close the second parentheses, and then we raise that to the 1/4 power. So that gives us 3. Then on the right side, we have parentheses 69, and then minus 2 times negative 6. Close both parentheses, and then raise that to the 1/4 power. And we still get 3. So that is the correct answer. It is not extraneous. Okay, number 27 says the square root of 2x is equal to x minus 4. So we're going to put it in parentheses and square it. And we're going to do that on both sides. Now remember, if you have x minus 4 squared, that's going to give you 2 parentheses of x minus 4. So you're going to distribute. So you get x times x is x squared. X times minus 4 is minus 4x. Minus 4 times x is minus 4x again. And then minus 4 times minus 4 is plus 16. So this right side is going to be x squared minus 8x plus 16. And we have just regular 2x on the left. And then I'm going to subtract the 2x. 0 is equal to, what is that? X squared minus 10x plus 16. And then we should be able to factor this. So two numbers that multiply to 16 but also add to 10 are going to be 8 and 2. To make it a negative 10, it's got to be a negative 8 and a negative 2. So x minus 8 and x minus 2 are my factors. That means that x has to equal 8 and x also has to equal positive 2. The signs just flip. So I can check this without the calculator. I could just type this, like do this in my head. 2 times 8 is 16. The square root of 16 is 4. And then 8 take away 4 is 4. So it's 4 on both sides. So that's good. Then I can check the 2. 2 times 2 is 4. The square root of 4 is 2. But when I put 2 minus 4, that actually gives me negative 2. So that one gives me 2 equals negative 2. So that's bad. That's going to be my extraneous solution. Okay, the next problem is done exactly the same way. We put it in parentheses and square it. So that's going to give me x plus 3 and x plus 3. So that's going to be x squared plus 3x plus another 3x plus 9. So this right side ends up being x squared plus 6x plus 9. Then I have 7x plus 21 on the left. Then I'm going to subtract 7x from both sides and subtract 21. So I get 0 is equal to x squared minus x minus, what is that? Let's double check this to make sure I'm doing it right. Oh, I have a typo here, even though I'm not typing. That's not a 12, that's a 21. Sorry. That's my dyslexia showing. This is minus 21. So that gives me a minus 12 here. So that means that when I factor this, two numbers that multiply to 12 and add to 1 are going to be 3 and 4. To get a minus 1, it has to be minus 4 and plus 3. So that means that x equals negative 3. and x equals positive 4. So again, I'm just going to do this kind of in my head here. 7 times negative 3 is negative 21. Negative 21 plus 21 is 0, and the square root of 0 is 0. Then if I put a negative 3 on this side, negative 3 plus 3 is 0. So that is true. 0 equals 0. If I put in a 4 over here, 7 times 4 is 28. 28 plus 21 is 49. The square root of 49 is 7. And then 4 plus 3 is also 7. So 7 equals 7. So neither of them are extraneous. Okay, number 29 says the cube root of x minus 4 plus 7 is equal to 18. So I'm just going to subtract 7 from both sides first. So I'll have the cube root of x minus 4 is equal to 11. And then I'm going to raise it to the third power. So I'll have x minus 4 on the left, and then whatever 11 to the third power is on the right. See, 11 to the third power is 1331. Then add 4. So I get x equals 1335. Then if we go and check it, I can check that in the calculator really quick. Shift parentheses, 1335 minus 4, then go outside the parentheses and put plus 7. If this is correct, it should give me an answer of 18, which it does. So that is not an extraneous solution. That is the final answer. Okay, the next part is all the real life problems. So it says the formula for the area of an equilateral triangle is given by a equals the square root of 3 over 4 times s squared. It says find the length of the side s of an equilateral triangle whose area is 12. Now, if they're telling you that the area is 12, they're telling you that a equals that square root of 12. So all we have to do is plug that into the problem. So we'll have 12 equals square root of 3 over 4, s squared. Now, if I want to get this s squared all by itself, I have to multiply it by the reciprocal of that fraction. So I'm going to multiply it by 4 over the square root of 3. Make sure that 12 stays into the square root. So then I'm going to multiply this by 4 over square root of 3. All of this fraction over here will cancel, and we'll be left with s squared equals. I'm going to type that into the calculator and see what it gives me. So 4 over the square root of 3. And I want to times that with the square root of 12. And it tells me that the answer is 8. So then what I want to do is, to get the s by itself, I need to square root it. And because this is a real life problem, I actually do want the decimal instead of this radical that the calculator spits out. So I'll just hit the FD button. So we'll call it 2.8. So the side would have to have 2.8 as its measurement in order for it to give us an area of the square root of 12. Now it says what happens to the side of the triangle as the area gets larger. So let's think about this. If I have a triangle and I want the space on the inside to get bigger, the only way I can do that is to make the size of the sides get bigger as well. So these ones have a direct correlation. That means as one goes up, so does the other. So it says what happens to the side of the triangle as the area gets larger. If the area inside is getting larger, that means that the side gets larger. Okay, next problem, very similar problem on the next one. Velocity of a free-falling object is given by v equals 2gh, where v is the velocity, h is the distance that the object has fallen. On Earth, g is equal to 32, so that's a big one. We're going to plug that into the problem. It says, how far did the object fall if it hits the ground with a velocity? So they're telling us that v is equal to 80. So we're going to plug everything in. So let's start off with 80 equals the square root of 2. We know g is 32, so I'm just going to put that in there. And the only thing we don't know is h. So 2 times 32 is 64. So 64, and we have the h inside with equals 80 on the left. 64 has an answer. That's just 8. So 8 is outside of the square root, and h is inside. And then I just divide by 8. So I get 10 is equal to the square root of h, and then I square it. So that means h is equal to 100. So in order for the velocity to be 80 feet, the height has to be 100. How far did the object fall to the ground if its velocity is 48 feet squared? Or same problem, you just put 48 on this side. So 8 square root h, divide by 8, divide by 8, square root of h is equal to 6, and then we raise it to the second power, so h is equal to 36. What happens to the height when the velocity decreases? So again, a lot of these things are direct correlations. So as velocity decreases, the height decreases. So think of it as like the speed, kind of. As the speed goes down of this falling object, the reason why is because you're dropping it from a lower point. So the height decreases. Okay, now we're going to get into key features of graphs. So for graphing, we're actually just going to put it into the table, and I paused the video because I typed in all 4 graphs, or all 3 graphs, into the table. Now before you go into that table, you want to go into check your settings and make sure it's set from -10 to 10. And the first one is going to be the cube root of x plus 1 plus 2. Now I don't graph decimals, I only graph the wholes, so -9, let's get a fatter marker. -9 is going to be right here. And then I'm going to scroll until I get to the next whole number. So at -2, it's at +1. And then at -1, it's at +2. I want to talk about that point I just put there. Remember the h and k stuff? This is h and this is k, but h is opposite. So my vertex would be at -1, +2. So we don't need the calculator for that particular point. And 0, 3. And we just scroll down until we find the next non-decimal. 7, 4. And honestly, I mean, you can graph the decimals if you want to. The more points you have, the more accurate your picture gets. But that looks like those are the only ones that are not decimals for me. So I know that the graph of a cube root goes kind of off into the right, up into the right, and then down into the left in curves. And then key features, the x-intercept. The x-intercept was at -9, 0. The y-intercept was at 0, 3. The domain for this graph goes left forever and right forever, so it's going to be -infinity to infinity. The graph also goes down forever and up forever, so it's going to also be -infinity to infinity. And then the graph for the increasing segment, this graph, if you were to write it as a roller coaster, it never stops going up, so it's only going up. So the increasing segment is from -infinity to infinity. So if it's always going up, that means it's never going down. So the decreasing segment would just be none. Okay, number 33. It says graph x plus 1 in parentheses to the 1/2 power and then -2. So like I mentioned before, the h and the k, h is inside with x and k is on the outside. H is the one that is our hater, so it lies to us. So that's going to be -1, -2. So I know the starting point for this shape is at -1, -2. So let me head over to my calculator, go back to my equations. Square root of x minus 3. If you guys notice, I typed it in as the square root of x minus 3. That's because anything to the 1/2 power is just a square root. So that's why I typed it that way. Now this one, hang on a second. I think I actually am looking at the wrong one. No, I did type it in. Okay, yeah. So x plus 1 to the 1/2 power minus 2. There we go. I almost turned on the wrong graph. So this one still has a bunch of errors. You're going to see the first point that actually works is at -1, -2. And the reason for all those errors is because if you go to the left of this point that we already have, it gives you a negative inside of a radical, so it doesn't work. So 0, -1 is the next one. And we have a point at 3, 0. And if I just keep scrolling on the calculator, there's another point at 8, 1, which is the last one that's going to fit. So this one starts at this bottom point and goes up into the right curved. Okay, number 34. Number 34 actually does have some key features that we have to talk about. So let me go into my graph here, turn this one off and go back up to this one. So if you guys remember, I don't really need the calculator to find the vertex of my graph. The vertex of this graph is going to be at +3, +2, sorry, +3, +2. So that point right there is going to be the starting point for this graph. Let's see what this looks like. So we'll have a bunch of errors till we get to the point that we just said. +3, +2 is the first point. Then 4, 1, 4, 1. And then 7, 0. And that's the last one that fits. So this one is going to curve down into the right. So it's going to go kind of like this. The x-intercept is at 7, 0. The y-intercept, it doesn't touch the y-intercept because the point farthest to the left is at +3. So if you go anywhere to the left of that, it gives you the error in the calculator. So that's none. The domain is going to be from where it starts on the x-axis. So it starts at 3, has a black dot, and goes to the right forever. So it's going to be bracket 3, parentheses, infinity. The range is going to go from the lowest to the highest. The highest y value is at 2, so it's going to be +2 with a bracket on the right side. And then it's going to go down forever, so it's going to go to -infinity on the left. Now this end behavior is kind of weird. Usually our end behavior has infinities all over the place, but this one's going to have an actual number because it's got a sort of like an ending point. So the first one says as x approaches 3. So when we're talking about the x approaching 3, we're talking about it approaching this point right here. They want to know where is y going? Well, y is going to 2. And then as x approaches infinity, that's going to be this end. That's going to head down forever, so that's going to be -infinity. So anytime your graph doesn't have an arrow on one side, it's going to use numbers for the end behavior, both for the x and the y. Okay, next it says, what is the equation of the graph? Now, this graph right here, this is the h and this is the k. And pretty much from that, we should be able to determine which one is the correct one. So if it has a k of 2, that means that it needs a +2 at the end. And just by process of elimination, you can get rid of choice A, C, D, and E. A doesn't have the +2 at the end. C has a -2 at the end. D has a -2 at the end. And E doesn't have a +2 at the end. So B is the correct answer. Should be the square root of x minus 3 and then +2 on the outside. We're going to do that method again for this. This next one is another graph and it's another multiple choice. This one has the h and the k at -2 and +1. So the first thing I'm going to check is, does it have a +1 at the end? So I can get rid of choice B, choice C, and then choice E. Now, if you guys look at the next thing, the h is -2, so that means that it needs to have a +2 on the inside, which it does. The only difference between choice A and choice D is that choice A has a positive in front and choice D has a negative in front. If you remember what the A value does, the A value flips the graph upside down. This graph is headed down instead, so choice D is the correct answer. Okay, number 37 says describe. Describe is where you use your words to say how it moved. Describe how to obtain the graph of cube root of x minus 2 and then plus 4 on the outside from the graph of the cube root of x. So if I'm just looking at the x, it started off at x equals 0 for the first one, which is actually this one down here, and it went to x minus 2. So that means that it went right 2. Then at the end, it went from 0 to positive 4, so that means it's going up 4. Those are my answers. Okay, given f of x is equal to x to the 2/3, g of x is equal to 2x to the 2/3 minus 3, and h of x equals x to the 1/2, perform the indicated operation and then describe the domain of each new function. So it's important to know that when you're going to explain the domain of the new function, you need to know the domain of the old function. So f of x is a cube root. Cube roots have a domain of negative infinity to infinity. G of x is raised to the 2/3 power, which is also a cube root, so that's going to be a domain of negative infinity to infinity. And then x to the 1/2, that's a square root. Square roots have domains from 0 to infinity. So this one says f plus g. So if I'm doing f plus g, I'm going to have x to the 2/3 plus 2x to the 2/3 minus 3. And when the x's match, you just add the front. So this is 3x to the 2/3 minus 3. Now the domain of this is going to be negative infinity to infinity because it's still a cube root. All cube roots have domains of negative infinity to infinity. Number 39 is pretty much the same problem, except they want us to subtract. When I subtract the g problem, I have to put it in parentheses, so that way that negative can distribute. So I'll have negative 2x to the 2/3 plus 3, and then I'll bring down x to the 2/3. So 1x to the 2/3 minus 2x to the 2/3 is minus 1x to the 2/3 plus 3. And then they want us to find the domain. Anytime it's got a bottom of 3, that means it's a cube root, so the domain is going to be negative infinity to infinity. Okay, now they want us to multiply f with h. So the f problem is x to the 2/3. They want us to multiply that with the h problem, which is x to the 1/2. Anytime you multiply stuff with exponents and the bases match, you just have to add the exponents. So let me go ahead and do that in the calculator. So I'll go to the regular calculator in the menu. I will hit 2/3 plus 1/2. So I've got x to the 7/6. That's my final answer. Now you have to pay attention to the bottom. The bottom is a 6. Anytime it's a multiple of 2, it's going to have the same domain as this one here. So if I have x to the 1/2, that domain is going to be the same as x to the 1/4, x to the 1/6, 1/8, 1/10. As long as this bottom is even, they all have the same domain. So that means that this problem is going to have a domain from 0 to infinity. Okay, the next one says g of x divided by h of x. So x to the 2/3 divided by 2x to the 2/3 minus 3. Now, there's not a whole lot you can do to this problem. We would be able to subtract those exponents on the x, but the issue is that it's got stuff around it, so you actually just can't touch it. And then for the domain of this one is going to be pretty much everything except 0. You can't have a 0 at the bottom of this guy right here. Even if it is a cube root, the fact that you have something at the bottom, it means that you can't, it doesn't exist basically. So my domain for this one would be all numbers except 0. So we write it like so. Okay, the last one says h of x times h of x. So x to the 1/2 times x to the 1/2. If I do x to the 1/2 times x to the 1/2, I just add 1/2 plus 1/2. Half plus half is 1, which I don't need to write the 1, so it's just x. And then the domain of x, that's going to be negative infinity to infinity, because it's just a line. And I think, here we go. So 43 says sketch the graph of an even function. Remember what an even function looks like? An even function is when the y-axis splits it in half. So if you draw a graph that looks like a V shape or a U shape, and the vertex is on the y-axis, that is going to be an even function. Number 44, how do you determine the solution of a system of equations from a graph? You just have to check where they cross. A solution to a system is anywhere where the two graphs cross each other. Okay, the next one says simplify. This is a division problem. X to the third plus 3x squared minus 4x minus 11 divided by x plus 2. Now I like that it's an x plus 2 because I can do synthetic division, which means I put a negative 2 on the outside. Then on the inside I'll have 1, 3, negative 4, and negative 11. So we always drop the first one and then multiply. 1 times negative 2 is negative 2. Then we combine. So 3 take away 2 is 1. Then we multiply. 2 times negative 2 is negative 2. Then we combine. That's negative 6. Then we multiply. Negative 6 times negative 2 is positive 12. Then finally we combine. Now this last term right here is always the remainder, and we'll deal with that in a second. When we write our final answer has to have letters back on it. So since the highest exponent is x to the third, I'm going to drop this down to x squared plus x minus 6, and then plus the remainder, which the remainder is 1 over x plus 2, and that's my final answer. Okay, it says write the equation of a quadratic. Now, a quadratic is something raised to the second power. It's been shifted left 3 and up 5 from the origin and stretched by a factor of 3. Okay, so if I'm going to write a quadratic, I'm going to put parentheses with an x on the inside, and that's going to be an exponent of 2 on those parentheses. If I wanted to go left 3, remember the left and right, that's the horizontal shift, and that's the one that lies to you. So if you wanted to go left 3, you put it as plus 3. And up 5 is going to be the number that goes at the end. So plus 5 goes over here at the end. And then stretched by a factor of 3, that's the a value. So I put a 3 in front. So there's my equation. Y equals 3 parentheses x plus 3, quantity squared plus 5. Now, I know that was a long video, but hopefully it'll help you. Sorry, my voice sounds hoarse. I'm a little sick. But yeah, I just wanted to record this video for you so you guys could do good on this last test.